Okay. Equations that represent functions are often written in function notation. So this would be function notation. F of x equals 4x minus 1. So this here is function notation. This could be an F, it could be a G, lots of different letters. So what that means is that this here is the f of x is representing y, but it's also a function. So we've talked for the last couple of days about what a function is and what is a function.
Oh, is f a function?
Well, not necessarily. I mean, it is because it's f of x. Not just because it's x. If it's g of x, it's also a function. So it's the notation. Gotcha. Good question. So what does function mean again? That's right. For every x value, there's one and only one y value. So there's a one for every input. There's one output. Okay. If there's more than one output for an input, that means it's not a function. So this reads as f of x equals 4x minus 1. Sometimes students want to read it as f times x. It is not a multiplication. It's notation f of x, which means it's a function. Do you remember seeing that before? May not remember what it was, but at least remember seeing it. So f of x is the function notation. And 4x minus 1 is the expression. So function notation is especially useful for finding a value in the range that corresponds to a certain domain value. So if f of x is 4x minus 1, we are fine. We want to find, say, f of negative 7. So that's what we're going to be doing today. We're going to be finding numbers in here. Okay, can I move on to my next slide? Yeah. Okay, so we have f of x is 2x plus 9. And if f of x, did I skip one accidentally? Sorry. Let me go back on the first one. Here's number 1. We want to find f of 3. F of x is negative 3x minus 2, and we want to find f of 3. So this here, this is an x value. Remember, this is f of x, so the 3 is my x value. So I'm going to take my equation here and substitute, or my expression, and substitute the 3 in place of the x. So I have a negative 3. When I have a number next to the letter, it's multiplication. So it's negative 3 times 3 minus 2. So I just substituted the 3 in place of the x. You ever seen that before? Yes, okay. So now what do we do first to simplify this? The multiplication or the subtraction? Multiplication. So this gives us negative 9 minus 2, which is negative 11. So you can think of this as addition of the opposite. So f of 3 is negative 11. So I want you to do number 2 on your own.
Does it tell you? Like, so everything would be equals -3. Parentheses -2.
Okay, so f of -7 is going to be -3 times -7 minus 2, or 21 minus 2, which is 19. Questions on that? Okay, so the next one, it's got f of -2 plus 9. So we're first going to find the f of -2. So we have -3 times -2 minus 2. And then the last thing we do is add that 9. So -3 times -2 is 6. Minus 2 plus 9, which would be equal to 13. So we are taking what that f equation is, so we're doing what it says for that f of x, which is -3x minus 2.
Oh,
Does that make sense?
whenever the number is.
Yep, we're just substituting it in.
That's not because it is not the
That's because it's not, that's right, we do it last. Exactly. We want to do what's inside in that function part first. Okay, so now we've got a little more complicated equation. There's more than more x in this equation. So what do? So we put the 2 in for this x, and then we put the 2 in also for this x in both places. So 2 squared is 4 minus 10 plus 7, which is 1. So h of 2 is 1. And then h of -5, we have -5 squared minus 5 times -5 plus 7. So I put the parentheses around there because we need to square that. So this gives us, what does this part give us here? 25. So we have to take a -5 times a -5, 25. And then plus 25 plus 7. So that gives us 57. So h of -5 is 57. Okay, pretty straightforward so far, hopefully. Let's go on to the next one. Okay, so this time it says f of x is 2x plus 9. If f of x is 15, find x. So this looks different, doesn't it? It says f of x is 15 and we want to find x. So where do we put the 15 on this one?
What do you,
Yes, the 15 was we replaced the f of x with a 15 this time. So it's 15 equals 2x plus 9. Do you see the difference there? So again, this time we have f of x is 15. We didn't have f of 15. A really common mistake on this one is students want to put a 15 in place of the x.
oh, it's what equals.
Right, so this time it's f of x is 15. So then we're taking the equation and setting it equal to 15. So now how would we solve for x? What would we do? Subtract 9,
And then divide by 2.
get 6, and then divide by 2. So x is 3. So see the difference there? Because in my last class, I got lots of questions of, wait a second, what is it that we set it equal to that? Right? Emphasize that a little more. Okay, so similar here, h of x is negative x minus 14. If h of x is negative 2, we want to find x. So where do we put the negative 2? I know Derek knows. Yes, we're putting it in place of the h of x. So negative 2 equals negative x minus 14. See the difference there? So then what do we do next?
Oh, I got it. 14.
Yes.
You add the 14.
Yep.
Oh, then you have to multiply by -1.
Okay, so next step, we could either divide by -1 or multiply by -1. This is like a -1 in front of the x. Get the same answer either way. And we get x is negative 12. Okay, similarly on this one here, p of x equals x plus 7 over 3, and p of x is 13. Where do I put the 13?
13 equals.
In place of the p of x. So 13 equals x plus 7 over 3, and then we want to solve for x. So what would we do next?
Multiply by 3.
Multiply by 3. We want to get rid of that fraction. So multiply by 3 is good. So 39 is x plus 7.
37.
X 7.
X equals 32.
And we get x is 32.
Wow.
Okay, the next one looks hard, but it's not. It's
No, we got
much
it.
easier than it looks. What do you think we do? So whatever's inside there, we substitute the x with that.
So 6m.
Yes, that's right. So it's going to be f of m is going to be 6m plus 7. Can we simplify the 6m plus 7?
Yeah, we probably add the 7. Or minus the 7. Look, can keep it like that.
No, we're going to keep it like that because we don't know what f of m is equal to. So we're in these two are not like terms. So that's going to be our answer.
When would you switch to 7? Or like, would you ever?
When would you? So if this was a number here, then we'd subtract the 7 from both sides. Yeah, but it's not a number. Yeah, great. Everybody still looking at this? So the last one is more visuals.
So actually, no, well, not all the time, sometimes.
Okay, so we got a graph now that we're going to use to evaluate. And so this is our function f of x. This graph is our function f of x. So we want to find f of -1. This -1 represents an x value or a y value?
Wait, what?
Just the -1. Yeah, so our x is -1, but you're right, the f of -1 represents a y. So we want to find an x value of -1. So we're going to go on our graph, x value of -1. Here's -1 on my x-axis. So I'm going to go up or down to find that point. And so to get to the graph, it would be this point here. Does that make sense? So now, what is the y value that goes with that point? 1, 2, 3, 4, 5. So yes, -1, 5. So f of -1 represents the y. So my y value is 5 there. So f of -1 is 5.
We just try to find the y.
Yeah, exactly.
And then the second one would be 0. Because you don't.
So f of 4, we're going to find that again, this is x equals 4. So we want to find 4 on the x-axis. So 4 is this point right here. X value is 4 is right there. It's a point already on the graph. What's the y value of that point? 0. So this is equal to 0. So f of -3. Now we're going to find -3 on the graph right here, and then we're going to go down. Now make sure you get to a point that is right at the corner of the box. And that would be this point right here. A little hard to see when it's such a curve, when that slope is so steep. So what's that y value there? -1, 2, 3, 4, 5, 6, 7. So that is equal to -7. And last one. This time we say f of x is 9. So what does 9 represent? The x of the y value. It represents the y value this time. So our y value is 9. So we're going to look on the y-axis for positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's this point here. We'll go left or right. So there's the point on the graph. What is that x value? 1. So x is equal to 1.